Hello there. We're starting our first graph problem, which is wonderful because we're moving along swiftly. We are doing number 79 of our Neetcode 150s. We have a number of islands. This is a great problem, very good beginner problem for graphs. So graph is basically a 2D. It's very similar to this particular problem that we've done in backtracking. I think it was called letter combinations. No, that was not letter combinations. This was word search. Yeah, we can basically replicate that code here, get a condition, and that condition is if we check every single item, basically like word search, and if it's a 1, we keep going and we make it all zeros. Then we go up to the next location, check for 1s. If it's a 1, then we basically set a new island, and then we eliminate all of those 1s connected to it, and that's it. So we're gonna do in this particular video, we're gonna do recursive. This is the first way. Then we're gonna do it iteratively as a breadth first search, and we're gonna do it iteratively as a depth first search. This is going to be a very good video to learn about breadth first search, depth first search, and so on and so forth. Because the only difference between depth first search and breadth first search is that we're gonna go in one direction, finish that off, then we're going to go in another direction, finish that off, and then go into the other directions and finish that off until it all becomes 0. Other than breadth first search is just keep going it at and radiate from a particular point. And the way to use it iteratively is just to use a stack or a queue, which is popping off front or back. I mean the stack is first in, first out, and the queue is first in, last out. And that's about it. I mean, first in, first out for a queue. Yeah, first in, first out. And first in, last out is stack. Yeah. All right, let's start. So in all of these problems, we need to set a row and column. And we also need a edge case if not grid. Let's just return here first, and let's set our rows and columns, length of grid and length of grid 0. This would cause a problem if there was no grid and we tried to get the 0th item and there's nothing there. Okay, so we'll set the results equals 0, and let's for I in rows, range rows, and for j in range columns. So we look at every single spot as we said earlier. And we either run a DFS here, ij, and convert everything if it is an island. So if grid of I and j is equal to 1, then that means that's an island. So res plus equals 1, and we run DFS or BFS, depending on whatever we want to run first. This particular item is going to be turn it into everything surrounding it becomes a 0. Everything it touches becomes 0, and with that we won't count it again next time. So once we're done, we return res. So either BFS or DFS. Let's just do DFS for now. It's going to be pretty quick. So let's define it here. Define DFS. All right, with I and j, all very simple. So the first is the base case. What happens is that if, let's say, row and column, it's easier in I and j. Sometimes row is less than 0, that's out of bounds, or row is greater than or column is less than 0, out of bounds, right? Or row is greater than the rows, greater or equal to rows. So that means it's out of bounds. Or columns is greater than or equal to columns. So it's also out of bounds. Or grid of is already 0, so we don't want to move on. So that's pretty simple. And with that, let's return. Otherwise, let's run the DFS call on everything around it. So let's set the current part to RC equals 0. And then once that happens, we just run DFS like nothing, like nobody's business. So R plus 1 C DFS R -1, C, DFS R, R, and C +1, and DFS R, C -1. That's it. That's all the code we need. Believe it or not, this basically goes through all the code and sets everything to 0 if it's connected. So, and yes, let's run it. Let's run the test cases. Whoops. Yeah, very good. Let's submit. That was a very quick solution, extremely quick. But now let's do BFS. So BFS is pretty much very similar, but we can't, of course, by recursion, we have to use a stack. We're using a stack, but by BFS, that's the only way to do it is iteratively at this point that I know of. So it might be that I don't know anything, don't know any better. So anyways, so BFS, we create a queue, and in that queue, we append R and C. So while queue, R and C, equals to q.pop left, and once we pop left, we're gonna add, we're gonna make sure that grid of R and C is equal to 0, and yeah, and if we basically do the same checks again right here, copy that, continue basically, and if otherwise, set it to 0 and run our code. Basically, add these to queue. So R +1, R -1, C +1, C -1. So that goes through the four directions, and we check everything through the queue. And so with that, we set everything to 0, and we don't count them again. So let's change this to BFS, and let's run that. Yeah, very good. Let's submit. Very good. That looks good to me. And if we want the iterative for the BFS, we just run that, and we just pop instead. So now we have all 3 solutions. Thank you very much for watching. I hope you learned something today, and you enjoyed the video. That's all the code there is. Of course, let's switch this back to pop left to make sure that we see the correct code. Well, I hope you learned something today. If you enjoyed the video, like and subscribe. If you want more, check the link in the description below. And see you next time. Thank you.